it's 10,000 e to 0.025t plus 15,000 e to negative 0.04t. Okay, perfect. It's not a friendly function, right? Good. So they're asking us to find whatever, max or min. Good. So obviously I have to find a prime of t. So 10,000 is the constant outside. E to this prime will be e to this times 0.025. So I have 10,000 times 0.025 times e to 0.025t. A negative will come down, 15,000 times 0.04 and times e to negative 0.04t. Did I assign this problem for homework? As you know, I did not write solutions yet.
Yeah, that was
okay. I will waive this problem today because I did not show an example like this in class. The difficulty part is not the calculus part. The difficult part is solving the algebra, solving the equation. That's what we do this in college algebra, but maybe you didn't do it, or maybe nobody showed this to you. So I will not grade this problem. So don't worry about it. But we have to finish it. So I have to determine or solve the equation a prime of t. This is equals 0 because this is never undefined. So there is this portion will never be undefined, and this portion will never be undefined. So a prime is never undefined for critical numbers to come from that source. Okay, so we have to solve this. So first of all, we have to multiply these. So I'm multiplying by, so 1, 2, 3, 4. So this is 250 e to 0.025t minus, so 4 times 15 is 60. I have 3 zeros, but 2 will go away. So to 600, e to negative 0.04t equals 0. So the difficulty part is here, the algebra, and solve this equation. Here's how we do it. We have to divide both sides because this is never 0 and this is never 0. We have to divide both sides by one or the other, either e to blah, 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 or e to this. So I will divide by e to negative 0.04t. So 250. When I divide this piece by this piece, this e to this e, I have to copy the base and subtract the exponent because it looks like this. 0.025t divided by e to negative 0.04t. When I divide two exponential notations with the same base, I copy the base and subtract from the exponent of the numerator, I subtract the exponent of the denominator. But when I subtract a negative number, I'm really adding. So this becomes e to 0.065 t. 0.025t plus 0.04t minus 600. And when I divide this by itself, I get 1. Of course, I will move 600 and divide by 250. And I have 600 over 250. You don't have to worry about simplifying this. It doesn't really matter. But how do I solve this equation now? So this was the difficult part, to remember that when you have this situation with two e's, you can divide by one or the other to simplify. I cannot proceed here before I just get one exponential expression and just a number on the other side. So what will be the next step now? Of course, I can simplify by 10 and more, but it's not important. So what do we do next to determine t? Yes. So we apply natural log here, and we apply natural log here. This comes in front, and natural log e goes away because it's 1. So I have 0.065t equals this natural log of 60 over 25. So I'm going to write it again because it's here in the corner and I don't like that. So you don't have to copy it again, but I will copy it here. And then I divide by this number. Okay. Perfect. So now I plug this in the graphing calculator. Okay, natural log 60 divided by 25. And then further divide by, it's just one number. You know I love parentheses, but in this case it's okay because it's one number. So 13.5, approximately 13.5. What was the measurement unit? Oops, I didn't mean to stop sharing. What was the measurement unit? Where is it? T years. Okay, years. After Jeff's initial investment. Fine. Good. So we haven't finished. This is just the critical number. So now since we're talking about years, of course this is not the case, but you know what I mean. This is what I determined. So now I go back. This is the derivative. Ugly. So I'm going to copy it here one more time. A prime of t to 50 e to 0.025 t minus 600 e to negative 0.04 t. At this point, I have to find the sign here and here. That's the way I justify what this gives. So whatever this is, then a of 13.5 will be that max or min. I don't know. I can go back and look and see what they're asking. So they're asking how many will be to be properties be a minimum, and what will be the combined value. So I know what it should be, but I have to justify correctly and make sure that I entered everything correctly. So what I'm going to do, I'm just gonna in y equals, I'm gonna put this function, the a prime, the 250 e to 0.025x. You know me, I don't like no parentheses, but I'm gonna swallow hard this time. And accepted, because not all calculators have that, so that option. So let's see if it allows me to continue. I normally don't trust it. I put my parentheses in. So second, so what I'm going to see, it's very clear. So this is negative, and a 30 is positive. That's all I needed. So I checked the signs. This is definitely a relative, or if you want to call it local, it doesn't matter, minimum. No question. I also checked. So this is decreasing here and increasing here. This must be a relative or local minimum. Now, how do I determine this? Now I have to punch in the function to determine the actual value. So go back to y equals, and what was the function? Initially it was 10,000. And e to, what was it? Yeah, same thing, of course. 25t and plus 15,000. And then the same thing with that e to negative 0.04 t. So that's all I need is 13.5 roughly. So that's the second function. Okay. So this is 22755.62. 22755.62. And that's I'm assuming it's dollars. It doesn't say, but the combined value. Okay. Any questions on this? Naja, is this better? Did you understand my steps here? Everyone understood steps? All the steps?
Yes, it's a lot, but I think I've got it.
Okay. Of course, I'm going to post. Yes?
But I wasn't sure if you were supposed to just look for the years or the like both.
Oh, but we know that. The critical number is for years, right? The function is value. The independent variable is years. So that's why this is your critical number. It's always the case. The independent variable will give the critical number. The dependent variable will give us the max or min. For any function. It doesn't have, we don't even have to discuss any particular function. For all functions, the independent variable x gives the critical number, and y gives the max or the min, always. That's why we have, so let me reach this for a second one more time. It's a very good question. So here it is. The critical number is x. The actual y value is the relative max or the relative min.
Okay. I mean,
Better?
I think it just asked for minimum.
Say it again.
It didn't really say. It didn't really ask for a critical point. It asked for a minimum.
But you cannot find a minimum if there is no critical number.
Okay.
That's the starting point. You have to determine a prime, set it equal to 0 or be undefined, two sources. You have to find critical numbers. If there are no critical numbers, the function has no max min.
Okay.
So that's the first step we studied in max min, critical numbers. No critical numbers, nothing. So that's why I was asking, when you get a chance, just look through the videos. It will help you cement what we studied and what we talked about in class. I guarantee you, if you try to do that. Good, excellent. Any other questions? Do we understand all the answers? Is this okay, everyone? Are we ready to move on?
Yes.
Okay, perfect. So what I would like to continue with today is the next section, which is the 3.3, in which we're going to do exactly what we did before so far. In 3.3, we're going to look at rational functions, rational and other types. Of functions. Okay, so these are very different than what we looked at so far in 3.1 and 3.2. In 3.1, we didn't even graph. So I would like us to start with a simple example and go through the exact same steps. So what page am I on? I'm on 305. So, and you will see what is different in rational. So right now we're going to look at rational. Allow me to choose the first problem in rational. I'm going to start with, I'm not going to answer just this. I'm going to graph the whole thing. So I'm going to start with problem 2. So in 2 on page 305, we have a rational function, 2x minus 3 over x minus 5. Okay, how do we start? So for this function, again, we are asked everything. And from the everything from last time, we're going to have to add a few more things because this is a different type of function. Okay, so what is the starting point when we are asked to graph a function? Always. Like with
Domain.
Yes, thank you so much. Yes, absolutely. Domain is the first step. Can anyone look at this function and say, oh, this function has a problem? And the problem is, and I will put it in writing,
Denominator cannot be 0.
x minus 5, excellent, cannot be 0, which makes x cannot equal
5.
perfect. Now I get my chart going. I start building it right away. Every time I find something, I put it in. Find something, put it in. Find something, put it in. So f prime of x, f of x, and of course the second derivative. Good. This is the first thing you told me to put in. I'm going to put it in. It's very clear. I don't have to write the domain in any other way. What is the domain? Everything except 5. If the function is undefined at 5, of course its derivatives will not be defined. We know that a function is differentiable if it is continuous and it doesn't have a cusp or a corner. This function doesn't even exist. So of course the derivatives will not exist. Good. Now I have to fill this in with everything I can. X and y intercepts, limits, and after that I can study the first derivative, and after that I can study the second derivative. Right now I'm still here. What do I want about the function? So let's write those. So for f of x, any limits asymptotes. I'll explain this. You probably remember from college algebra. Vertical, horizontal, oops, slant. I think this is a little bit stretching it in this class, but we will talk about that too. Okay, x and y intercepts. I can't find anything about the function other than limits, any limits that are needed, asymptotes if they exist, and of course x and y intercepts. So let's start with a simple one, the x and y intercepts. So here's the function again. How do I find, let's say, the x-intercept? And then how do I find the y-intercept? Anyone? Yes?
X-intercept y equals 0.
Of course. Thank you very much. And I know you're going to say x equals 0. Awesome. Can anyone plug in x equals 0 and give us what this equals to? I cover them up because they're 0.
Real, we're fine.
That's it. So the ordered pair is 0, 3/5. I found something. When x is 0, the function is 3/5. Perfect. Now let's find y equals 0. Solve the equation y equals 0. 2x minus 3 over x minus 5 equals 0. When is a fraction 0?
When the numerator is 0.
Excellent, of course. When the denominator is 0, we have other situation. Excellent. So 2x minus 3 equals 0. We know we move 3 divided by 2. X equals 3/2. So 3/2, 0. I found something. I place 3/2 exactly where it belongs. And I place the 0 under it because that's where f of x is. Good. So this is done. Oh, this is done. So now let's talk about any limits. For now, I need to determine this limit, and I need to determine this limit, because the rest of the limits are connected. There will also those, but I'll come back to the rest. So I need to determine the limit of the function as x approaches negative infinity and put it here. Then the limit of the function as x approaches infinity and put it here. So that's our next step. Limit as x approaches negative infinity from 2x minus 3 over x minus 5. And then limit as x approaches infinity from 2x minus 3 over x minus 5.